Hi all, and welcome to the Stewardship Network's monthly webcast. Great to be with you on this, our monthly webcast on each and every second Wednesday during the Eastern Time Zone's noon hour. And I'm really pleased to be here today with Dylan Skybrook and Kass Green to talk about vegetation mapping for landscape stewardship collaboration. Dylan and Kass, looking forward to learning more about your project. I want to welcome you all, and I see many returning Stewardship Network monthly webcast members as well as new folks. So just want to welcome you. Encourage you to make liberal use of the chat box and the Q&A, and let us know where you're tuning in from, and let us know any technical questions that you have. Rob's right here to help answer any of those questions. As I said, I'm Lisa Brush with the Stewardship Network, and I'm really pleased to be here today with Dylan Skybrook from the Santa Cruz Mountains Stewardship Network and Kass Green from Kass Green and Associates. I want to take a little moment to tell you a little bit about the Stewardship Network. Our mission is to protect, equip, and mobilize people and organizations to care for land and water in their communities. We are the capacity builders that provide the backbone support to all of you out there doing the work that you do. Our work is to keep you outside and doing the work while we provide the tools and resources to make you more efficient and effective. We are a national and international award-winning organization for revolutionizing the way that land and water is cared for. We have thousands and thousands of partner organizations that we work with. We have 30 different member communities, and we look forward to working with you all as well. You all online are a great representation of the kind of partners that we work with, from all volunteer groups to global and international groups, from municipal, state, federal, tribal, governmental agencies and units, contractors and consultants, students, volunteers, homeowners, private property owners, you name it. And those kinds of groups are part of the work that the Stewardship Network works with. We have our collaborative conservation communities, our member communities. For those of you who've been part of the Stewardship Network for a long time, you know that we used to call those our local clusters. They are locally defined and controlled. They are made up of the organizations and individuals in a specific geography that care for land and water. It's all about making room at the table for everybody in the community and thinking about revitalizing the system as a whole. And if you are interested in learning more about starting one of these collaborative conservation communities in your community, you can email us at staff@stewardshipnetwork.org. We hold an annual conference each and every January, and our virtual conference registration is live now. It will be January 27th, 28th, and 29th in 2021. So I encourage you all to go to conference.stewardshipnetwork.org, register. And one of the things that we're doing, it's going to be 3 half days, and the registration is going to be $99. We want to make it accessible for folks to come and join in. We'll have a combination, just like we did with our in-person session. There will be networking times to sit around and meet people, as well as the presentations. We will have our bookstore, as we always do. We will also do a virtual water ceremony like we do. We'll have our story slam again. So it'll have all of the same features, but we'll all just be sitting at home. No travel needed for this year. I would also like to thank you all online who have made financial contributions to the Stewardship Network. Your tax-deductible contribution enables us to broadcast these free online monthly webcasts, as one example, as we've been doing for nearly 200 webcasts. We've been doing them back in the day when people were like, whoa, webcasts, and now this is what we all do. We all sit around and Zoom. I also want to let you know that right now, any and all donations that you make are matched 2 to 1 right now, and we just up to $400,000. So make a contribution of $5, $50, $500, $5,000. We really appreciate your support. So thank you so much for your support. As I said, I'm Lisa Brush with the Stewardship Network, and I'm about to turn it over to Dylan and Kass to talk to us about vegetation mapping project that they've been working on.
All right. Thanks, Lisa. Really glad to be here to talk with you all. I'm going to share my screen here. Okay, so first, just hello to all my Midwestern brothers and sisters. Although I'm living in California these days, I'm from Minneapolis, Minnesota, which I miss. But I'm the manager of the Santa Cruz Mountains Stewardship Network. And I've also brought Kass Green here today, who is our technical advisor on our vegetation mapping project. And we're really lucky to have her working on the project and to have her speaking today because she knows everything. I'm pretty convinced. She's going to describe the project. But first, I'm just going to talk a bit about the Santa Cruz Mountains Stewardship Network. The Santa Cruz Mountains are right below San Francisco on the central coast of California. And our network is made up of 23 organizations that own or manage or in some way steward land in the Santa Cruz Mountains. And we have a really diverse membership in terms of stewardship types. Our members are land trusts and public agencies, universities, timber companies, special districts, the Amamutsan tribe. So there's a lot of different kinds of organizations doing different things on the land, but who are all working together to help the region thrive. And I think just like many networks, our network is a vehicle for these organizations to collaborate on issues that cross property lines and jurisdictions, county lines, so on. It's an opportunity, the network is an opportunity for everyone to think at a landscape scale, and not just thinking about their own separate properties and so on. These are some of the representatives to the network at one of our convenings. We have 3 convenings a year where we really take an emergent approach in which we have conversations, we discover shared purposes. Some of those shared purposes are then turned into teams where people can work together on the issues that are important to them that do cross boundary lines and so on. So we have a climate team, invasive species team, fire and forest health team, permitting streamlining, and so on. Some of the ideas get turned just straight into projects where we also get other people to help us make those happen. And that's really what happened with the vegetation mapping project. And we brought in Kass and a few other folks to help us make that happen. We also have several salons per year, which are just essentially peer-to-peer sharing opportunities where we talk about grazing or restoration forestry or mountain biking. These are convivial events. I have them catered. We have snacks, or I did do that in the before times. Now we do it on Zoom. And of course, a lot of the work happens, I think, like in every situation, on the sidelines during coffee breaks and so on. So a lot of what we do is focus on trust building to make sure that we're creating the conditions by which that kind of self-organized collaboration can happen most easily. We also, depending on what the teams are working on, we have workshops going on quite frequently. Coming up, we have a climate adaptation workshop and a diversity, equity, and inclusion workshop. In the past, we've had workshops on monitoring invasive species, permitting, streamlining, and so on. This is a map of our region. If you look at the very top of the map, that little bit above the yellow line, that's San Francisco, just to help you locate yourself. And the yellow outline here is, that's the boundary of our network. It covers, but doesn't completely include 3 counties. So the top county here is San Mateo County, and you can kind of see over here this black line that gets a little bit lost amongst the different properties, but that's the county line between San Mateo and Santa Clara County, and then below down here is Santa Cruz County. And it's really the mountainous forested areas that are a part of our network. It's the Santa Cruz Mountains bioregion. On the right here, you can see a list of some of our members. They're the ones who own properties. And you can see the different properties outlined in different colors there. It's interesting because it's a kind of patchwork quilt of ownership, and it really speaks to the need for there to be a network for all these folks to work together and to think at a regional scale. There are other network members too, like the Amamutsan tribe, who don't technically own any property, but of course, their territory covered a lot of this region historically. And they work with a lot of the different members stewarding land. Also, we have CAL FIRE, who is responsible for all the forested and wildland areas. And we have the resource conservation districts that help private landowners steward their land. So it's a big mix of different properties, jurisdictions, territories, and so on. So one of the things that's interesting is there was already a vegetation mapping project happening in San Mateo County, the top county there. And Kass was working on that. She also worked on projects in Marin and Sonoma counties, which are a little bit to the north of us, above this map. And so what was happening is there was kind of a data cliff as you crossed the county line down into Santa Cruz or over into Santa Clara, where we couldn't see things consistently. That, you know, the data in Santa Cruz and Santa Clara was older and coarser, and we really needed things to be consistent to have this kind of big picture view to help us think at a landscape scale or at a regional scale. And so it really made sense for this project to happen, and it really made sense for our network to be the one who was kind of the container for it. To get this done, we had to build a coalition of interested parties. It was a $3.5 million project. So we had to get a lot of different people interested. So Kass and I and our colleagues, Danny Franco and Mark Tuckman, did about 1 million presentations to try and really explain what the value of this project was and what people would be able to do with the data. And we've been pretty successful. We put together a really diverse portfolio of funders, including many of our network members, but also we got some of the counties involved, we got foundations involved, and so on. And so we've been able to do quite well. We're in the middle of the project. We're not done with it yet, but it's going well. Then the last image I want to show here before I turn it over to Kass, this is a satellite image of the same region. Again, you can kind of see at the top here is San Francisco, and all this darker area is the forested mountainous areas, and that's kind of our region. And if you look near the bottom, just to the right of center of screen, you can see this kind of big charcoal sort of oval shape. And that's where one of the catastrophic wildfires happened. You know, you probably have heard of many of the fires that happened this summer. And so you can see, comparing it to the map I just showed you, that this was in our region, and it burned many of the properties of our network members. It's about 85,000 acres, that particular fire. There were a bunch of other fires in California, but the one in our region was about 85,000 acres. And so it just kind of shows that's exactly the reason that we needed to do this project, because there are always, I mean, fires always looming in Central and Northern California. It's these kind of cross-boundary issues, why we need to work together, why we needed this big picture vegetation map. And in fact, we were able to turn over some of this data to CAL FIRE that they were able to use in response to the fire, even before we're done with it. So we can already see it being valuable. So that's what I got. That's an introduction to the network. And I'm going to turn it over to Kass now. And then once she's given her presentation, you can ask us about the network or about the project or whatever. So thanks, and take it away, Kass.
There you go. Thank you, Dylan. Want to make sure you guys can see my screen?
Not quite yet.
Not yet.
So thank you very much. My name's Kass Green, as Dylan said, and I also will claim to be a Midwesterner because I spent the first 14 years of my life in Cincinnati. And there is a cultural difference in between the West Coast and the Midwest, let me tell you. But now I'm a real Californian. So I'm going to talk about the innovative technologies and funding strategies that we've used in this project, and go into them, just so we can pass on a lot of our lessons learned. Whoops. So,
Kass, I actually can't see your screen right now. I'm not sure if others can.
Okay. How about now?
Yep, now I'm seeing it. Yep.
There we go.
Thank you very much, Rob. So I'm going to first do a summary of San Francisco Bay Area Finescale mapping projects, not just the Santa Clara and Santa Cruz ones, but the other ones that Dylan was mentioning. Then we'll go over some of the innovative technologies we've been using, which have really reduced costs, but also improved quality. And then I'm going to briefly talk about successful fundraising strategies. And Dylan already gave you a pretty good introduction to that. And then we'll finish up with the value, how users are value the actual data that's coming out of these projects. So as Dylan said, the project started actually in Sonoma County in about 2014, and the county's agricultural and open space district decided they needed a Finescale map. And by Finescale, we mean these maps are at the alliance level, which I'll go into in a minute. And they're usually about 100+ classes per county. And so they're very, very detailed. Minimum mapping units of 1 acre to a 1/4 acre to an acre. So very, very fine scale maps. So start in Sonoma County. And then next thing happened is Marin County liked what they saw in Sonoma County. So they called us up and said, can we do something in Marin County that's similar? And I actually was on the verge of retiring. But I had told my colleague, Mark Tuckman, that the only reason I would not retire would be if Marin County called, because I spent the rest of my childhood in Marin County. And so that's my home. And it took them about 2 weeks to call. So I haven't stopped. I haven't tried to retire since then because I'm having too much fun. So after Marin County got online, then San Mateo County called also. And it's usually not the county that calls. In Marin, it was Golden Gate National Parks Conservancy. In San Mateo, actually, one of the big pushes came from CAL FIRE, but it was also National Park Service. And then after that, last year, we added Napa County just for fuels mapping, wildland fuels mapping. They already had a Finescale map of their own. And then Santa Cruz and Santa Clara counties. So I'm going to focus on the Santa Cruz and Santa Clara projects because those are the projects with the network. But as you can see, we're building a region-wide data set. So it'll be good for managing on the ground, but also for region-wide analysis. So the projects are, Sonoma, San Mateo, and Marin, and then Santa Clara and Santa Cruz. The costs go up because the acres have gone up, but actually the price per acre has gone down over the 6 years that we've been doing this work because of technology advances. So what actually gets produced for the users? Lidar data. We'd started with Q2, but immediately all the users wanted Q1 Lidar data. So all the counties have Q1 Lidar data. Some of the counties were already collecting it. In some other counties, such as Santa Cruz, we actually did the contracting and collected the data. 6-inch multispectral ortho imagery, a very generalized life form map and land use map. This is a 20 class map that talks about the major land uses, and it's like hardwood versus conifer trees, agriculture, grass, so that it's very generalized map, but still very useful for planning. Then we're creating 5-meter wildland fuels maps for all the counties. Ladder fuels, which is an important variable in fire behavior. It's the fuel on the ground up to the canopy of the trees. So it's usually from 0 to 12 feet. And it's very important in the spread of fires. The topographic layers that we all expect, this is from the Lidar data, slope, aspect, elevation, shaded relief. For Santa Cruz and Santa Clara counties, we are also building a wildland fire risk index, which is a very complex layer that brings in weather factors, ignition factors, and then fuel to show across the landscape what the risk of wildfire is. Then canopy cover, height, base height, bulk density. Those are all variables that go into wildfire modeling models that some of you are familiar with Farsight. And so we also produce those. Impervious, pervious surfaces mapping, which is critical for flood control and flood management. Then the big ticket item is items are the countywide classification, which is a detailed descriptions and keys to all of the classes that are mapped in the Finescale map. So that's a big step. And that's done by California Native Plant Society and the California Department of Fish and Wildlife. So we work with those on each county to develop those. Then we have data access portals. And I'm going to show you an example of one of those in a minute. This is critical in these type of projects, is you've got to give easy access to the users of the maps. And then finally, the the Finescale vegetation map and accuracy assessment, those are 100+ class maps. Again, 1/4 acre to 1 acre minimum mapping unit, very detailed. And I will show you some examples. So here's some of the products. These are just example products that come out of these projects. Got the imagery, the Lidar, got data sets that are built from the Lidar, like vegetation height and hydrology. At the Finescale vegetation map, building footprints. This is just some of the data sets that end up being produced. We're mapping the vegetation to the alliance level. That's a NVC, US NVC, National Vegetation Classification, designations of different levels, hierarchical levels of vegetation. And we're down here at the most detailed level, at mostly the alliance level. Also, sometimes we go down to the association level. And these are based on, on the ground conditions. So again, you're building vegetation maps that can be used to manage on the ground for local management, but also can be expanded across the region for region-wide management or county-wide management. So we're at this detailed level down here. So what made these programs possible? And there's several factors, and I'll give you some detail on some of them. Continued decline in the cost of ortho imagery and Lidar data collection and processing. The cost of especially ortho imagery, has really, really gone down. And I encourage you all to look at NAPE imagery if you haven't yet. It's National Agricultural Imaging Program imagery. It's flown 2 to 3 years by the Department of Agriculture. It's on a 2 to 3 year cycle. Luckily, California's on a 2-year cycle. It's at a 1/2 meter spatial resolution, but the companies that do that work also fly at a lower altitude, and for a very low price, you can get 6-inch resolution. So give you an example, Santa Clara County is over 1 million acres, and it's going to cost us about $15,000 to get the NAPE upgraded product for all of Santa Clara County, which was just flown in the summer of 2020. So if you're looking for imagery, go to NAPE first and consider the upgrade product, because it's a really good deal. We are also, yes?
Can I ask you, while you're talking about the imagery, can you talk a little bit more about what Lidar specifically is, and what's the difference between the Q1 and Q2? Sure.
So Lidar is a relatively new technology, which means it's 20 years old, but it's what's called an active sensor. So as the aircraft goes over, instead of just capturing the reflected rays from the ground into the imager, which is what we do with multispectral imagery, it's a passive system, and we just the sensors just measure the reflected energy from the ground. In Lidar, it's an active system. And so as the aircraft goes over, it sends down a pulse, multiple pulses, and the aircraft moves and it receives back a pulse from the ground and from the canopy and from the middle of the canopy. And so it depends on the detail of the Lidar, but it's an active sensor, and it gives this really detailed representation because we've built a triangle from the airplane to the ground, back to the airplane. And by measuring that, we actually measure the speed of the return of the Lidar pulses. We get a very, very detailed digital terrain model and a digital elevation model and a digital surface model. So we can measure the ground because the returns hit the ground. And that gives you your, without vegetation, your digital terrain model. But then also it hits the tops of the canopies. So you can measure canopy height and building height. And it also hits the middle. So you can look at vegetation structure. So it's expensive technology. It's gotten a lot cheaper over the years, but it's really, really powerful. And we use it in all of our mapping projects. And luckily, USGS is trying to build a nationwide data set of Lidar imagery that they post online. So if you're working on a project, go to the USGS site, see if Lidar already exists. It's called the 3DEP program, 3DEP. And if you look at the 3DEP program, what they've acquired, then you can see if Lidar already exists for your area. For USGS, it's usually Q2 Lidar. So that means 4 pulses per square meter. 2 pulses per square meter. That's Q2. That's still pretty detailed. So 1 square meter, you got 2 pulses coming down to the ground, hitting the in-betweens of the structure and then the top of the canopy. Q1 is 8 pulses per square meter, much more detailed. So if you've got thick forest lands and you want to see underneath that canopy, the Q1 is going to be much better. And especially in Santa Cruz County, where we've got dense redwood forests that are really, really tall. The trees are, really tall. And you want to get the precise location of a stream underneath or any roads or what the terrain is. And I'll talk about this in a minute for the CGU fire. That Q1 Lidar is worth the extra expense, but you got to measure it. If you don't have a lot of tall, close canopy trees or big canyons, you can probably do with Q2. We just finished a project in Elkhorn Slough, which I'll show some examples of, but we use Q2 Lidar on that. But these Bay Area projects are more Q1. Did that answer your questions?
Yes, that does. Thank you. It's amazing the technology, right, that we now have.
Oh, it's awesome.
Yeah.
Yep. And so much of it is free or close to free.
Yeah.
So again, look at that NAPE imagery. Look at and in the public domain, look at the 3-depth USGS program for LIDAR. You'll probably find that a lot of, if you want to start a mapping project, a lot of what you need, the foundational data sets, which is the imagery and the LIDAR, are already there in the public domain. So that's the first thing, is there's this continual decline in costs. Then another thing is the reliance on the National Vegetation Classification Standards and the standard map classes. And this is critical if you want to build data sets that are usable at the local level, but expandable for regional analysis, because you've got to hit those standards. And the standards are good. These are excellent people that have been working on these for decades, and they really are coming together. And so I would really encourage any mapping project you're going to use, start with NVCS first, instead of trying to make your own labels. You can always, you can always add more classes if you need for your specific area, but you should start with NVCS. Then the third thing that's happened is the implementation of innovative technologies. And I'm going to talk about these in a little bit more detail, but image segmentation, machine learning, GPS-enabled digital field data collection, all these technologies save money and they improve the consistency and the accuracy of the maps. And then fourth reason is we've got the ability to make the products widely and easily accessible. So no longer do we need to deliver data by hard drive, but we deliver it on the web and it's always accessible. So I'll talk about that a little bit more in detail. And then finally, the economies of scale from region-wide cross-organizational collaboration. When you do these consortiums, cross-organizational collaboration, you can build the funding that's necessary, as we've been able to do with the Santa Cruz Mountains Stewardship Network. It's building that, and that was a perfect home for this project because they already had this collaboration going. So it's really important. So we'll talk about methods. We're talking about innovative methods, but I'm going to start with the basic ones, which is if you're going to make a map, you got to understand what causes variation on the ground. You got to understand what causes variation in the imagery and ancillary data, and you've got to link those two. So when the imagery varies with what's going on in the ground, you can easily use the imagery to make a map. And when they aren't correlated, when the imagery doesn't vary with what's going on the ground, you got to find another way to map those classes. But these are the 3 basic steps, whether you're doing it for manual interpretation or semi-automated classification. These are the 3 basic steps. So the first one, understanding variation on the ground. Even though we do a lot of automation, we still go to the ground. And actually, it's the best part of any mapping project. These, besides my husband, these are my 2 favorite, some of my 2 favorite people. This is Mark Tuckman, who is Tuckman Geospatial. They actually make the maps. Mark and I have worked together for 25 years now. And his company's been doing all the technology innovation. And then this is Mike Vasey, who's, the king of wetlands in the San Francisco Bay Area. But again, we have a vegetation classification scheme development by California Native Plant Society and California Department of Fish and Wildlife based on field samples. That gets us to those 100 plus classes and the descriptions and the keys for those classes. Then we also, on top of the field work that's done to build the classification scheme, we also do calibration trips before the map's made and validation trips afterwards. So we do a lot of automation, but you still got to go to the field. And as I said, it's the best part of the project. So then you want to understand the variation in the imagery and any ancillary data you might get your hands on. So we use multiple imagery types. We use Landsat and Sentinel, which are coarse images in the public domain. Landsat's a 30 meter pixel, Sentinel is a 20 meter pixel. They're coarse, but the neat thing about them is they go overhead. One of those satellites, or the constellation of satellites, goes over every 3 days. So for mapping deciduous forest versus evergreen forest, you get a June image and you get a fall image. And if it's deciduous, the fall image isn't going to have leaves in the fall, but it's going to have leaves in the spring. And if it is evergreen, it's going to have, green response in both time frames. So this it brings multi-temporal into your allowance analysis. Again, free data in the public domain, accessible on the web. But of course, to do the fine scale mapping, we also have to have high resolution imagery. So this is Elkhorn Slough watershed in Monterey County, California. This is the true color. This was the NAPE upgraded product that we bought here. Cost us, I think, $7,000, maybe $5,000, to get the entire area at 6 inches. So NAPE, again, is free at 0.5 meter, but we need 6 inch to do the level of work we're doing. So, and NAPE imagery is also multispectral. So you've got infrared, and it's a 4-banded data set. So you've got really rich data set. So we've got the Landsat data, better temporal resolution. We've got the high resolution airborne imagery. And then we bring in a lot of ancillary data. This is a shaded relief from the Lidar data. Again, we got this from the 3DEP program, from USGS's 3DEP program. So again, that was free to the project. And from the Lidar data, we can get vegetation height, canopy percentages, ladder fuels, all kinds of different other data sets that are derived. And then we get every piece of data we can that already exists in the area. Existing plot data, tidal stages, historical maps, everything. This is a kind of a group of ancillary data sets that the Elkhorn Slough Foundation had, and we used to make the map. So you just get every piece of other data besides the imagery and Lidar, and you bring that into the project too. And you do analysis on this data so you can understand what causes variation in this data and and if it's varied from your imagery, what's causing that. Then the next step is image segmentation. This is automated image segmentation. This is the Elkhorn Slough area again. We've zoomed in to the slough itself and some of the wetlands and uplands, and we do automated image segmentation. So instead of having the human photo interpreter delineate the different vegetation types on the imagery, we do this in an automated fashion. We're using eCognition software to do this. It's a little bit expensive, but it is the best. But ESRI and other companies also have segmentation algorithms that you can use to segment your image. This is probably the most expensive step in some ways. The field work is the most expensive. But technically, this is an expensive thing to do because of the cost of the software. Also, you've got to go back and forth until you get the delineations right. But it also saves the most money. So it's a really, really important step. And then you're always editing. These are never perfect. So you've always got to go in and edit these things to some extent. Then we link the variation on the ground to the variation in the imagery and the ancillary data. So this is from our field data collector. I told you earlier that all of our data collection is done on an iPad in ESRI's collector app. So this is Marin County. We're out in the field in a wetland. In the collector app, we've delineated this segment and are labeling it. It's pickleweed. Here's a photograph of it. We collect multiple sites to build a sample data set across the landscape of all the different vegetation sites. So here you can see that area expanded with lots of, I'm sorry, that was testiculus, not spartina, not pickleweed, but you can see lots of different vegetation types captured across the landscape. So we'll do, when we're out in the field, you know, we're doing well over 1,000 samples per county. But this is much faster than trying to do manual mapping. So you're spending probably the same amount of time in the field that you would do for manual interpretation, but you're spending less time actually making the map. So the next step is machine learning. And I know this is a buzzword, but it really does work. We've been doing machine learning for probably 20 years now. It gets better and better. The algorithms get better and better. But with machine learning, you're taking those samples that we had on the ground and you're dropping them through the imagery, but also through all of your ancillary data sets. And you use machine learning. We're using random forest most often now. You use the machine learning, then the machine learning develops rules for each one of the vegetation classes. So vegetation class is your dependent variable, and your ancillary, your imagery and your ancillary data are your independent variables. And it builds rules for every vegetation type. And then those rules are expanded across the rest of the area to come up with what we call the preliminary map. So you intersect your training segments with the independent variable layers. Then machine learning predicts the vegetation classes. Then the model is applied across the unsampled areas. And then finally, we do editing. So we don't cut the human out by any means. What we do is use the computer to map the easy classes. And we retain that expensive human photo interpreter to deal with the difficult classes. So some of the variables that get used, I'll take everything. I'll take the kitchen sink. But canopy, slope, stream center lines, you know, all the multi-data, multi-spectral imagery, Landsat, and the high-resolution imagery, geology, fire history, fog occurrence. It goes on and on. In the Sonoma project, we had 314 independent variables in that project. So that's 314 maps of the area we were mapping that helped to feed into the map and create the rules. And then once that's all done, so we have a preliminary map is reviewed in the field first with validation trips in the field. Then there's a round of editing. Then the draft map goes out to whoever our partners are. That's done across the web now. They review the map, tell us where we've made mistakes. Can't tell you how important that step is because the users then create ownership with the map, which is critically important. Then we do more editing, and then we do the final map is delivered. So another point I made earlier is you got to make these products widely and easily accessible. If the products are inaccessible, they will have no value to the users. So you've got to make these products accessible. In the Sonoma project, Mark built image, clip, and email viewers. So you just go in and you can either clip out an area that you want and download all the different products, or you can actually pick a watershed and download all the different products. If you want the Lidar point cloud, which is huge, you still got to send a hard drive in. But all the other layers that I mentioned, all the other products, they're available on the web. And we're working, Dylan and I and other folks are working right now to figure out who's going to host the Santa Cruz Mountains Stewardship Network products when they become available. So, you know, it's always in a different place. but it's really important that this data be highly accessible. So what are the successful funding strategies? How do you, get enough money raised to actually do one of these projects? Because they are big, and they, we're talking over $1 million and several $1 million. So how do you do that? The main thing, and this is what you all know about because you're networks, is you build a consortium. And what it does is it lowers each organization per square mile cost by sharing costs across multiple organizations. It lowers overhead costs because you've got one organization managing the project instead of multiple organizations. It lowers your collection and processing costs because when you ask a vendor, a Lidar or an imagery vendor, to fly a county or several counties, their economies of scale kick in. And so instead of them doing multiple small areas, they're coming together and the price per square mile goes way, way down because they've got huge economies of scale. That's basically because they're bringing aircraft in. That's a huge cost for them to mobilize the aircraft. So if you put a larger area, the larger and larger the area, the lower and the lower the square mile cost. One thing to realize though, is if you're building different consortiums, each consortium is going to have different, will be different. It'll have different members and it's going to have different goals. And so we've watched Sonoma started because ag and open space needed to prioritize their acquisitions. Marin County started because the Golden Gate National Parks Conservancy had done an excellent job with the One Tam program looking at the health of Mount Tamalpais. And they realized they needed a map. And then once they wanted a map of Mount Tam, then the Park Service wanted a map of Point Reyes and the Marin Headlands. Then the county wanted a map of all their parks. And then the watershed wanted a map of all of their lands for the water agency. So it just built and built until it was really easy to do the entire county. Santa Cruz and Santa Clara, those projects have been driven very strongly by CAL FIRE and their need for fuels maps and management tools for preventing wildfires. So, but then all kinds of other members have different needs. So all the parks have come in and the water agencies. So each consortium is going to have different members and different goals, but they all need this fundamental data. They're going to use it in different ways, but they all need it. So Gillian gave you an idea of the members of the network. And here's just a splash of some of the funders that come together in these consortiums. Again, parks, open space districts, National Park Service, USGS, an important partner in every project. Excuse me, NOAA, foundations like the Gordon and Betty Moore Foundations, water agencies, Marin Water, Municipal Water District, Valley Water, state parks, private landowners like Big Creek, all different organizations who all need these fundamental data sets. So now I'm going to finish up with the value of the data to the users. And I like starting with these quotes. We actually did a user survey in Sonoma County. And it was, it's amazing, like stumbling into King Tut's tomb. We use the data every day. It's part of every map. We always look at it before we go to the field. It's fantastic, robust. This is typically what we hear from people about the data sets. Dylan mentioned recently the support to the CZU lightning complex fire. After the fire, because we had just gotten the LIDAR data for Santa Cruz County, we were able to create the LIDAR products that were important in the watershed emergency response team evaluation. And this is one of the many maps in this report. And you can Google it. Just Google CZ WERT report, W-E-R-T. And it shows, this is one of their maps about their debris flow models, the kind of debris flow they think will occur after the fire. And you can see a lot of the burn area is in high and moderate. It's a very scary situation down there. They were so happy with the LIDAR data that they got from us. They said they felt like they'd finally entered the 21st century. So there are lots of applications. They go on and on. This is just an example of some of the applications. that people are using the data for. So who uses the product? This is Sonoma County. Everybody uses these products. This totally blew us away. We thought it was all local government. You know, it's everybody, state government, commercial, the whole gamut. And what do they use that for? Everything. So they're mapping, they're using these maps to support all kinds of different applications. That's why there's such a broad base that you can build a coalition, because there's the uses are so broad. How often do they use the data? They're using it a lot. Again, this is only made possible because the data is accessible on the web. So lots of uses, but it's got to be on the web. How valuable is the data? You can see that every data layer, this is just the Lidar products, every data layer is mission critical to at least one organization. And the same thing's true of the vegetation products. Every layer is mission critical to at least one organization. What are the cost savings of this data to the different organizations? 26%, the respondents noted that their work quality would suffer or would take much longer to complete. But everybody showed cost savings. You know, time and quality are also cost. So you can see some of the, you know, big cost savings for the different organizations by having these data sets available. So the report that I just talked about on it's Sonoma County use, you can get that, you can find it on the web. Here's the site, you just Google the title. You can also find it if you want more details. People ask often about the value of the data. And this is one of the only reports I know of that actually goes in. We did a SurveyMonkey survey and goes in and evaluates the value. So I'm going to summarize. The technology exists to make semi-automated fine-scale mapping accessible. Semi-automated methods lower costs, but they also improve your consistency, they improve the detail, and they improve the accuracy. Consortiums are an effective approach to build funding and constituencies for these projects. In fact, I wouldn't try to do it without a consortium. And the value of the data sets is significant, allowing users to better meet organization goals at a lower cost. So thank you very much.
Thanks, Kass. And for those of you who tuned in a little bit late, we've been hearing from Dylan Skybrook of the Santa Cruz Mountains Stewardship Network and Kass Green, who, as Dylan said in the introduction, knows everything. So thank you for that. So Kass, a couple different questions for you, and Dylan too. What's the example of making it accessible? So is just having it on the web accessible? What are the subtleties around making that data accessible?
That's a really good question. The easy to use. So it's got to be like, you don't want people to have to be GIS specialists to be able to get this data and to be able to look at it. So we also do a lot of web maps. So people can, in storybooks, if you use ESRI software, that's a great way to get a case study, is to do a storybook. So it's got to be, you know, and this is slowly happening in this field. But it used to be you had to be an expert in GIS to be able to touch the data. And what you need to do is make it really easy, because the software exists, so there's no reason you have to be an expert to use the data. So it's you know, making it accessible. We also, for Sonoma, did a lot of newsletters, and Dylan does that too. We do updates all the time. So always communicating what you have and how easy it is to use. We do workshops where we train people how to access the data. So I think those are the subtleties.
That's great. Yeah, that's I think a really important part of it is how do you format it, and so it's a matter of and that's got to be, you know, just like the validation of the data and working with the partners, that has to be just a whole other stage of the process, right? It
is, though we tend to start it early. Because the vegetation maps take 2 to 3 years to make. That's a long time to have everybody wait for a product that they decided to fund 3 years before. But the Lidar products, you know, they're available right away. So, you know, that's why we're working so hard to get a hosting situation for the Santa Cruz Mountains Stewardship Network data, because we've got the LiDAR projects ready. They're being served right now by the Mid-Peninsula Open Space District, but we want to have a more robust hosting site. And so you get them out there early.
Yep.
You get you make it accessible as soon as you can.
And then Dylan or Kass, can you provide any links to some of the storybook use of it? And is that just on the same?
There's a really great storybook that was made after the 2017 Sonoma complex fires. And I'm going to have to send you the link to it.
Okay.
And don't look at it on your phone because it's too big and it's too slow.
Too much detail. Yeah.
Yeah. So look at it on your computer, but I'll get Dylan the link to that.
Okay, great. And then when you were doing veg collecting in the field, were you using collector or survey?
Collector.
Okay, great. And then you mentioned an app that you were using on the iPads.
Just collector.
Okay, just collector. Okay, great.
Yeah.
And then Chris asks, how much training and experience do you need to create the maps derived from the LiDAR data?
To actually make the LiDAR products from the point cloud, that takes an expert. But you can do that within like ESRI's got software you can push a button and do that.
Yeah.
To use the LiDAR products in the map making process is not difficult at all. The machine learning takes a little bit of a step, but it's not hard for bright people.
Yep.
And so, Mark doesn't have his master's. None of his staff has graduate degrees. They all have college degrees. But the thing that's most important by far, if you're going to make a vegetation map, is that you have a botany background or forestry background. That it's much more important for the person making the map to understand the vegetation than it is for them to understand how to use the computer. So I'd much rather take a forester or a botanist and teach them how to use ArcGIS.
Yep.
Than I would try to take a ArcGIS person from, say, the Department of Defense and teach them how to forestry and botany.
Isn't that so often the case, right? with so many of these things. And then Kass and or Dylan, can you talk a little bit about the field validation process? Like how much ground truthing, where do you decide where to ground truth? How do you
go?
Yep.
You go everywhere you can get access to. You don't spend a lot of time taking samples. These are not half-day releve samples. These are, you're getting 30, 40 samples a day, and you're driving around and you're just taking as many samples as you can. Now, before I go into the field, and this is the way it is for everybody, we've looked at the imagery. So we really know that there are things in the imagery that we don't know what they are because we looked at them and we can't figure them out. So you target those areas. Those are your high priority areas to go to, or any areas that look like they're confused. But you just get, it's very hard, I think, sometimes, especially for botanists, to switch out of I've got a sample and I've got to do these really, really detailed samples of every species that's on the ground. You're not going to map every species that's on the ground. You're going to map the dominant species. And so you go fast when you're in the field. We still spend days and days in the field, but it's a different kind of sample, and it's very broad. I just did Elkhorn Slough myself. I retain projects every now and again so I can have some fun in the field. And when we went out for the calibration, I was just trying to learn as much as I could about the area, but took tons of samples. When I went back for validation, I knew where I thought I had errors in the map, and I was focused on those areas.
Exactly. And then how do you course correct for that?
How do you mean course correct?
So once you know that there are areas in the map that you need to correct, that you need when you go down to field verify and you say, this is actually wrong, we need to adjust this.
Oh, I have Collector with me, and I changed the map while I'm in the field.
Right there.
Yep.
Great. And then can you talk a little bit more about as Dylan, you said in the beginning, you went to millions of meetings and millions of presentations. And I think it has to be pretty compelling for folks who have this technology. Is it the kind of thing that it takes, some big partner to get on board first? What's been your experience with that? Do you just begin to bring people on board? Does it take 4 meetings of going there to get decisions? How does that process work in putting together a big project like this?
Dylan, do you want to start that and then I'll follow up?
Yeah, sure. One of the things that I think is kind of evident from what Kass has been saying is that there are so many different kinds of organizations that want these maps, that want this kind of data, but they want really different things. So it's actually crazy. I'm from an arts background. I used to be a choreographer, and trying to get arts funding is always just this, kind of Sisyphusian sort of effort, where you just knock yourself out and someone finally gives you $5,000.
Right.
But in this case, in some cases, we'd go into an organization and they'd be like, oh yeah, for sure, here's 50 grand.
Mm-hmm.
It'd like be that easy. They'd be like, yes, this definitely should happen. In other cases, we would do, we would do presentations to multiple organizations at one time, and then they would want more information, and we'd have to go back, and then we'd have to go to Sacramento and talk to the people at the state level, and it would just be like this kind of big thing. And it partly depends on the organization, but it was certainly easier once we had 1 or 2 organizations that were willing to be public with their pledges, especially with bigger pledges,
Mm-hmm.
because a lot of what we found is everyone was like, well, what is everyone else doing? No one wanted to be the first one. No one wanted to kind of be hanging out there, maybe, giving too much or something like that, if there was going to be a bunch of people sharing it. So Kass and Danny did an amazing job of being like, come on, y'all, you gotta, one of you has to really come forward and be willing to stick your neck out and say that you're going to give this money.
Right. And Kass, with your experience in all these other places, you have the ability to just say that, look at what they're doing over there. It's time to get with the times.
Also, we don't go to counties or organizations and say, hey, we really think you should do this. They call. So somebody's already in pain and then they need a solution. And so that's usually how it starts. But Dylan's absolutely right. That anchor client, that's huge to have. For us, Gordon and Betty Moore Foundation came in with a $50,000 pledge, really early. And not only was it a good amount of money, but it was the Gordon and Betty Moore Foundation. And that really kicked off then other people started to come in. And that's the way it is in the San Mateo and Marin counties. It was a National Park Service. They were in pain and they needed more work done. So that anchor client is pretty important.
Mm-hmm. And Catherine asks about the vegetation maps, and this probably has to do with that Q1 and Q2 level that you talked about. Get to ground cover vegetation or just the forest canopy for classification?
All maps that are made from remotely sensed data, they're going to be based on the canopy in some way. You can pierce. The Lidar does pierce the canopy, so you can get measures of structure, of forest structure, vegetation structure through the Lidar. And that is one of the products that comes out of this project. But associations, alliances and associations have a ground component in them. And it's one of the reasons we can't get to association very often is because we can't get that ground component. So we're more at the alliance level, which is the dominant vegetation.
Great, thanks. Hey, as we're coming to the top of the hour, maybe one last question for you, and then we'll wrap up. But Chris wants to know, are there other similar mapping projects that you know of that are on this scale around the country?
Yes, Chesapeake Bay what are the Chesapeake Bay Conservancy, I think. They don't go to the level of detail we do, and I don't think they're using Lidar, but they are doing a, you know, for the whole Chesapeake Bay area, they're doing a more of the life form map that I talked about, the 20+ class map. So that's a good one to go for, to look at.
Great. Well, thanks, Dylan and Kass. I'm sure we could talk about this all day. I'm sure that you all could do multiple day workshops on this, but we really appreciate you visiting with us for the last hour and sharing your ideas and information. So thank you both so much. Really appreciate it.
Thank you. It was fun. Thank you.
Great.
Yeah.
And
thanks, Lisa. Happy to do it.
Absolutely. Great. Thanks. And thanks to all of you all online for spending the last hour with us. We really appreciate it. Want to again remind you that your contributions to the Stewardship Network, tax deductible contributions to the Stewardship Network, are being matched 1-for-1 up to $400,000 right now. So we appreciate any support that you can provide. Also want to remind you that registration for our virtual conference on January 27th, 28th, and 29th, 2021 is now open. Visit that, and we will be back together again as we are each and every second Wednesday of the month during the Eastern Time Zone's noon hour. You can put us as a recurring event in your calendar. Next month, we'll be visiting the Great Lakes. So we'll be looking at Lake Erie and the history of Lake Erie. So thank you all for being with us. And I'll look forward. Take care, be safe, and we'll see you next month.